Hey guys, welcome back. We got one more video for this chapter. Now we are going to start naming the bones. All right, we have over 200 bones, and no, we are not going to name them all. All right, the, just the big ones. All right, we don't have time or the energy to name all of them in one set of notes. So let's jump in and talk about the big ones. All right, before we start naming these bones, let's talk about organizing them. We can lump all of our bones into one of two categories. We can either call them the axial skeleton, shown here in purple, or the appendicular skeleton, shown here in hot pink. This is actually very easy to remember. Axial kind of sounds like axle. If you know anything about cars, that is a straight piece of metal going from one tire to another tire, holding them together, and that's what your axial skeleton is, just a straight line right down the middle of the body. And then appendicular has to do with your appendages, which is another fancy word for your limbs. All right, so this is your limb skeleton, upper limbs and lower limbs. So what makes up all of your axial skeleton? The bones that support the head, neck, and torso. The skull, made up of the cranium and the facial bones. The cranium is the top part of your head that encases your brain and keeps it safe, and your facial bones count as their own section. And yes, you are going to name all of these bones today. The hyoid bone, no, you don't see that in this picture here. So here it is for you guys. The hyoid bone kind of looks like the bottom half of those cheap Halloween vampire teeth, except that it's not in your mouth, it's in your throat. Right. This picture you're looking at is called your larynx. You know it better as your voice box. Your vocal cords are kept here. You may also know it as your Adam's apple. And yes, ladies, you have an Adam's apple too, it's just smaller. But on top of that is your hyoid bone. This shape, this bone keeps this open because not only do you talk with this, you breathe with this too. This is your air passage. So we don't want this ever closing. So your hyoid bone is there to keep the air passage open so that you can breathe. And these two little bottom fangs are there to attach to some ligaments that reach up and grab the sides of your skull to hold this whole structure up. Your vertebral column, we're going to go into more detail about in a little bit, but those are the individual vertebrae bones of your spinal column protecting your spinal cord. And your thoracic cage, we talked a lot about in the last video. Those are the bones of your thorax protecting your heart and your lungs. So it is made up of your ribs, and this bone right here in the middle kind of looks like a tie called the sternum. You may know it as your breastplate. Appendicular skeleton, the bones of the appendages. Starting at the top, we got what's called the pectoral girdle. Holds the upper limbs in place. Your pectoral girdle is made, that's hard to say, isn't it? Pectoral girdle. It is made up of two bones. This one here lit up in yellow, you know as your shoulder blade. It's actually known better as your scapula in science. And then this bone going across the top, you know it as your collarbone, is actually called the clavicle. And how it sits is on your rib cage, on your thoracic cage, the scapula sits on your back, and the clavicle reaches around the front as if it was a little kid on your back with his arms around front holding on to you so it can go for a piggyback ride. That is a weight support system for your upper limbs. That is how your arms hold on to your torso. Speaking of your upper limbs, those are part of your appendicular skeleton. We're going to go into more detail about naming those individual bones, but they're hanging off the side. Then we get the pelvic girdle, which is part of the pelvis, which is used to hold on your lower limbs, which are used for walking. So let's go into those individual bones. Starting with the skull, you have about 22 bones that we're going to go over. Like I said, we're not going to go over all 206 bones of the human body. That's too much, but there are a lot we're going to talk about, and 22 of them are in your skull alone. Now, I'm not sure how I'm going to have you guys taking your notes, writing these down, and normally in class, I would have a this picture in front of you and ask you to color in each bone and then label its name in the same color, the color code, the labeling, so it's not as messy and it's easier to read. Hopefully that's how we're doing it now. If not, go back to Google Classroom right now and check out whatever instructions I gave you for this. Your skull, like I said, is separated into your cranial bones, your cranium, and your facial bones. Your cranium has 8 individual bones, and your facial bones have 13. Luckily, a lot of these are doubled up, so we don't have to memorize as many. And at the bottom, we have the mandible. So let's go through them. We'll click on this in a second. In the front, and those are the name of it is right here, pops up when I color it in. This is known as your frontal bone. If you remember the last video, the fetal bone had 2 different bones here. As you grow, they fuse and become one frontal bone. If you need to pause and finish writing this down or coloring this in, do so, but I'm moving on. The side and the top of your head, known as the parietal bone, and you have 2 of them, one on either side. So there is a fusion point all along the top where those 2 meet. There is a suture all along the top where those 2 bones fuse together. Then on the side, your temporal bones. Kind of confusing in the name. When you think of your temple, people call that soft spot on the side of your head right here. It's actually named after your temporal bone. I guess somebody messed up at some point naming that, but no, this is not your temporal bone. This is your temporal bone, and it protects the temporal lobe of your brain. The parietal bone protects the parietal lobe, and the frontal bone protects the frontal lobe of your brain. As always, scientists are not clever when naming things. They try to keep them together. Then in the back is the occipital bone, and it protects the occipital lobe of your brain, having to do with eyesight. The part of your brain that controls your eyesight is in the back, not the front closer to your eyes. So this is the reason why people started wearing helmets in sports. Back in the day when people didn't have helmets or they had not as good helmets, they would get tackled and hit the back of their head and then lights out. That's it. So we have to protect that bone. Then on the side, this is known as the sphenoid bone. Oh, that was a weird word. Say that again, guys. Sphenoid. The PH makes an F sound. Right? Sphenoid. And if you look at this picture here, normally you would not see it in the eyes. The frontal bone and these bones, these cheekbones we didn't name yet, you continue into the eye socket and you would actually have more bone material blocking your view. This picture, those bones have been removed so you can see the sphenoid bone in the background. This bone actually goes through your skull and gives your brain something to rest on. So that's really cool. It's actually shaped like a butterfly, and I'll show you. So fast forwarding a bit here, we got the skull, and then all the bones we just talked about, and then the facial bones we didn't talk about yet. And those are all the sutures fusing them all together. And then underneath, all those holes are where nerves and blood vessels come and go, because your brain needs to communicate with the rest of your body. This big one is where your spinal cord enters your skull and connects to your brain. There's your occipital bone, your parietal bone, your temporal bone, your frontal bone, and then some face ones we didn't talk about yet. And then, let me rewind a bit here. This bone right here that's not lit up, right? Temporal bone's lit up, but the one right in front of it is the sphenoid bone. And it is going to continue right through the center of your skull. And that's what we're going to look at now. As we undo those sutures and remove the individual bones, we have this butterfly looking shape. And this part right here is what was on the outside that I pointed at, and this is the other side. Those on the outside, and this whole butterfly shape goes right through the center of your skull. So all of this right here is part of your nasal cavity. And then in the back, your midbrain area would be rest coming down where it connects to the spinal cord. It's going to be resting along this. It's a vertical piece of brain going against this piece. And the rest of your brain will be on top, getting some weight support from that bone. Fast forwarding in. And then we put all those pieces back together, and there is the wing of that butterfly-shaped sphenoid bone. The face. Your cheekbones are known as the zygomatic bones. Any of you who are getting into the medical field or training as an EMT, you will very commonly hear of a zygomatic fracture. What that means is someone took a hit to the face really hard and it broke a cheekbone. And then this is the nasal bone. Yes, guys, despite popular belief, your nose actually does have a bone in it. Put your finger on the tip of your nose, and you feel that soft, bendable, movable piece. Right? That is soft cartilage. And then move your finger halfway up where it just becomes hard. All right. It may be hard, but you can still move it side to side. That's because it's still not bone. That is hard cartilage. And then continue all the way up your nose until you're in between your eyes. And that hard part does not go side to side. That is the bone. That is the nasal bone. If you look closely in this picture, you'll see there's a line down the middle. It's actually two bones fused together. Your face is symmetrical, mostly. So every bone on one side, you have one on the other side. You have two zygomatic bones. You have two nasal bones. You have two maxilla bones. So this is going to be in between your nose and your mouth and just under your eyes a bit. One of the things they teach you in self-defense is if someone attacks you, this line right here under the nose above the two front teeth is a nerve, and that's where you want to strike. So that is a self-defense. I'm not encouraging you to fight, but in self-defense, that is a target that when hit there, a nerve will send the shockwave to your eyes and cause your eyes to water, blurring your vision, allowing the victim to get away. And then your mandible, also known as the jawbone. That is the only bone in your skull that is not fused in place because you need to be able to move that bone. In fact, that bone is not even really attached. It's kind of just sitting on a hinge, and it can actually be removed. It's only being held in place by ligaments. Moving on to your vertebrae. Your backbone, guys. All right, that's what you're looking at right here. It is a bone of the vertebral column. This is your biggest point of weight support. Literally everything in your body is attached to this, directly or indirectly. So your ribs are in each individual rib bone is directly attached to one of your vertebral bones. So your ribs that are supporting the weight of anything that you're holding in your hands, all that weight is transferring to your backbone. So be very careful about how you lift things. And the bones are also there to protect your spinal cord. Vertebral bones and spinal cord are not the same thing. Your spinal cord is actually a bundle of nerves inside the bones. So the bones have a hollow space where the spinal cord is resting. And that's what I mean. The thick part of the bones is your weight support. And then back here is the hollow space where your spinal cord is kept. And then you have these spines called the spinous process sticking out the back as a bit of protection and also prevent you from bending backwards too far. Because if you did, you would bend your spinal cord and give yourself permanent damage. So weight support, spinal cord, protection. Your vertebral column is made up of 33 individual vertebrae. And if you remember a previous video, I told you that some doctors would probably argue with me about that fact. And that is because they're not individual bones. It's not 33 individual bones. If you go down here at the bottom, this is called your sacrum. And down here at the very tip is called your coccyx. And those are actually 9 different bones, but they're fused together into one solid piece. I and many other scientists count them as separate bones. But if you don't want to do that, that's fine. But I am testing you on them being separate. So just remember it for the test. Those 33 individual bones are split into 5 different sections. Up here, this is your whole vertebrae here. So this, what I have colored in pink, is your neck. It is known as your cervical vertebrae. There are 7 bones of your cervical vertebrae. And they don't have their own individual name. They're just numbered because cervical begins with a C. It's called C1, C2, C3, C4, C5, C6, and C7. They make up your neck. So remember, 7 vertebral bones, 7 cervical bones. Then your thoracic vertebrae, there are 12 that make up your upper back. This picture doesn't show it, but this is where your rib cage is. So let me show you this picture instead, and you'll notice that your thoracic vertebrae sticks out a bit, almost like it's bent. Yes, it is bent. Bent on purpose because your ribs stick out further in the front and it has all the weight of your heart and your lungs and your liver in there. You can't be too front heavy, so your entire thorax is pushed backwards a bit to better balance yourself out. And each vertebrae has ribs coming out of it. Okay? So your thoracic begins with a T, so it's T1, T2, T3, T4, all the way down to T12. Each vertebrae, T1 up top, has 2 ribs coming out, one on the left and one on the right. And T2 has one on the left, one on the right. So 12 thoracic vertebrae. So that is 12 pairs of ribs. 12 on the left, 12 on the right. You have 24 ribs. And then your lower back is called the lumbar vertebrae. That's easy to remember, right? Lower lumbar. And there are 5. And yes, this is bent the other direction. Your thoracic vertebrae bent out, so your lumbar has to bend back in to counter that. So remember those numbers, guys. 7, 12, and 5. 7, 12, and 5. So yes, this will be on the test, and there is an easy way to remember this. 7, 12, and 5 is when the typical American family eats their meals. I'm not saying you do, but the stereotypical American family eats breakfast at 7 in the morning, eats lunch at 12, and eats dinner at 5. 7, 12, and 5, breakfast, lunch, and dinner. This pinkish purple one down here at the bottom, that is part of your pelvis. Right? That is protecting your backside. That is known as the sacrum, and is technically 5 individual vertebrae fused together, because you don't need a lot of movement there. So there was no reason to keep them separate. They fused for protection, but you'll notice, do I have a picture of it? Right. I don't have a picture of it here. I usually use my skeleton in the classroom. I'll see if I can find something to put on the screen.
A few minutes later.
I found a picture. It's almost as good. You see these yellow things coming out. In between each vertebrae, these yellow things are nerves coming out of the spinal cord and spreading across the body. That is how the nerves interact with all of your body parts. But down here at the sacrum, you see that even though it's all one bone fused together, there is more sections for those nerves to come out. Above and below those openings are going to be a different section that used to be its own bone. So that's 1, 2, 3, 4, 5, what used to be bones. And then below that is the next thing called the coccyx, which is 4 individual bones fused together. You know it as your tailbone. Yes, your ancestors at one point had a tail. No, they were not humans. We're talking evolution. So way back before humans evolved, our ancestors had tails. We don't anymore, but we still have a remnant of it. It doesn't do anything. It's what we call back in Bio 1 a vestigial organ, something that we have that we don't use. But it is part of the vertebrae, and it is 4 bones. And if you add all of them up, 7 plus 12 plus 5 plus 5 plus 4, you get 33 individual bones of your vertebral column. Your thoracic cage is made up of your ribs and this bone in the middle. You know it as your breastbone. It's called your sternum. And because your ribs come out of your thoracic vertebrae, you have 12 thoracic vertebrae, you have 12 bones on each side. right? 12 on both sides. That means 12 and 12, you have 24 ribs. And then the sternum in the middle. Notice this is colored in blue, right? Because that is not bone, that is cartilage, bendable cartilage. Now, because when you breathe, your lungs are going to inflate and your ribs need to expand to make up for that. So you have cartilage to allow for a little flexibility. Your pectoral girdle, we've talked about this a little bit earlier, made up of your clavicle and your scapula. Scapula is what holds onto your back, and clavicle reaching around to the front, acting as weight support for your upper limbs. I showed you this picture before, showing it to you again. Scapula, your shoulder blade, you know it as, sitting on your back. The clavicle, your collarbone, you know it, reaching around the front, and acting as weight support for your upper limbs. Speaking of your upper limbs, there are a couple bones that we need to talk about here. The first one is the one that we have been labeling in the very beginning. It is called the humerus. No, that's not your funny bone. I don't want to hear those jokes. The humerus is the bone in your upper arm. Your shoulder and your elbow are part of that bone. And then your forearm is actually made up of two bones called your radius and the ulna. If you look at it, these two bones, there is the radius, which is on the thumb side, and the ulna, which is on the pinky side of your hand. What's the point of having two bones in your forearm? Why not one? Well, take a look at this, guys. Remember, bones don't bend very easily, right? If it did, you would break them. But you need to be able to move. But your elbow is a hinge, like a door, which means it can only go in this one directional movement, up and down. And then your wrist can go like this and can go like this, but that's about it, right? But we have the ability to do this. And that's where your two bones come in. Go ahead and feel that. If you hold down here, you can try to feel the two bones. They don't move too well, but if you go up here, you can feel, well, this, you can feel the two bones wrapping around each other. So that is the point of the two bones. The radius on the thumb side and the ulna on the pinky side are going to wrap around each other so that you can get this range of motion. And yes, I am going to expect you to memorize that. Know the difference between the radius and the ulna. And how you're going to do that, you're going to do that the way I remembered it. Way back in the 90s when I learned it, back when everyone was like talking like this, man, because we were totally like wanting to be surfers or whatever. Like, and they would do stuff like this, right? We got the thumb and the pinky is on the underside. Ulna, under. Totally works. All right. And then you're left with the thumb. What do we say with the thumbs up, man? Back in the 90s, radical. Totally radical. Radical radius. Oh, works so well. So like, that's how you're totally gonna do this. Radius to the thumb, ulna is under. Moving on down to your hand. We got the carpals, metacarpals, and phalanges. Your carpals, those are your wrist bones. And yes, you have 8 individual bones in your wrist. No, I'm not going to make you memorize that. All right, I'm already giving you way too much as it is. I understand that. So I just want you to know that the carpals are your wrist bones. If you're interested in knowing the names of them, here they are. Go ahead and name them. All right. And then here, no, these are not finger bones. They look like fingers, right? No, they're not. Check this out. Let me overlap an actual hand. It doesn't really match up perfectly, but you get the idea here. Look at that. Those pink bones are not part of the fingers. Those are the bones inside the hand. Set it aside, you can see it. And then down here, yellow, purple, and blue, those are the finger bones. We know them as phalanges, and your phalanges are actually made up of 3 fingers each. If you remember the terminology from chapter 1, we talked about distal and proximal. Proximal means closer, distal means further. So these are your proximal phalanges, the yellow. The purple are your middle phalanges, and the blue are your distal phalanges. And here's a weird thing. There's only two in your thumb. You have proximal and distal. You don't have a middle. So when people ever ask you, why isn't a thumb considered a finger? There's your answer. Because fingers have 3 bones and the thumb only has 2 bones. All right, almost done, guys. Now we just gotta talk about the hips and the lower limbs, and we are good. All right. Your hips, your pelvis, is made up of 5 different sections. And good news, we've already talked about 2 of them. Number 4 and 5, the sacrum and coccyx were part of your vertebral column. They're also part of your pelvis. They're pulling double duty here. So we only got 3 new sections to learn for this: the ilium, the ischium, and the pubis. Unfortunately, these pictures are not too good two-dimensional. I think I have a 3D thing going. There it is. All right, this is your pelvis. Here we got your vertebral column, your sacrum and your coccyx, your tailbone there. And this is the front now. And we see that your pelvis looks like a butterfly. I didn't have a thing with butterflies today. It looks like a butterfly, and these are the butterfly wings. Those wings are called the iliums. This is an ilium. It is there for protection. So you can like hip check things without damaging your reproductive organs. And then your ischium, look down here, this circular bone underneath, right? That's the part you actually sit on. No, you don't actually sit on your sacrum or your tailbone. You'll break your tailbone that way. You sit on this round part called the ischium. And here's a question: why is there a hole in there? Because that's where your blood vessels go and your nerves go through there. That way you don't sit on your blood vessels and cut off circulation. Right? You don't lose feeling in your legs every time you sit down. That is a protective thing for you. So the round part is the ischium. And then when we come back around, here we go, right up here. This is the pubis. And then we go back to this, we see this picture, the red part here, your pubis is actually connected with a bit of connective tissue right there. And that is also known as you may also know it as your pubic bone. Anytime you have the word pubic, you guys are teenagers, all right? You've heard the word pubic before. You know what section of your body I'm talking about. That whole section will always use the word pubic. So your pubic bone, your pubic hair, your pubic region is all that same location. And then, of course, sacrum and coccyx we already talked about. All right, your lower limbs. Backtracking for a second. Right here, see that red, that connection point? This ball joint, that is your femur. That is your thigh bone connecting to your hips. And it is the largest bone in your body. It is the thickest and strongest bone in your body. It's the hardest bone to break. It has a tremendous amount of weight support going on right there. And then you got your tibia and fibula underneath. Tibia is this big strong bone, for again, big for weight support. And then this little one off on this side called the fibula. Why do you have that? For the same reason you have 2 bones in your forearm. They wrap around each other and give you a little bit more range of motion. They're not as good as your forearm, but they work pretty well. Here's what's not in your notes. I'm adding this in just for your own information. The patella, your kneecap. Why do you have that? You feel it. You know your kneecap floats around a bit, right? It's not fully attached. It's not. It is held down by ligaments. So what is the point of a kneecap? You think it's there for protection? Maybe. But really, it's actually about movement. Yeah, believe it or not, that little piece of bone actually helps you lift your leg. Your kneecap, your patella, actually helps you lift your leg up. Show you what I mean with that, guys. This model here represents your femur and your tibia. And then this rock is your kneecap, your patella. And these are the tendons pulling on your tibia to lift your leg up. So as the tendon pulls, your tibia gets pulled up with it, right? Nice and simple. Why can't it do that without the kneecap? Well, let's take a look. As the tendon pulls, it's a weird physics thing. Like the angle is just too close to the fulcrum. Remember the levers we talked about before? The angle is just way too close to the fulcrum that it's not going to lift very easily at all. So evolution gave us a kneecap to push those tendons and ligaments out just a little bit further and give us a little less friction. And the last thing we're doing is the foot. So starting with the tarsals. These are your ankle bones. Just like with your wrists, they were called the carpals and you had 8 bones. Here you have the tarsals and you have 8 bones. And no, I'm not going to expect you to memorize those names. But don't get them confused. Carpals for your wrist. Remember, ever hear of carpal tunnel syndrome? Right? It's a wrist issue. And then tarsals with a T are closer to your toes. So with a T. So tarsals. And then your metatarsals, just like your metacarpals in your hand were not finger bones, they were actually hand bones. Your metatarsals are not toe bones, they are foot bones. And then your phalanges, again, this word is the same. This one doesn't change. Your fingers are known as phalanges and your toes are known as phalanges. And just like before, you have the proximal phalanges, the middle phalanges, and the distal phalanges. And your big toe, just like your thumb, does not have a middle phalange. So it is different. All right, guys, that is it for the skeletal system. Go back on Google Classroom, see if I left you any work to do. Contact me if you have any questions about anything at all, and I will see you in the next video.